So let's start the today's session. We are going to solve recursive problem, right? So yesterday I solved recursive problem of these all questions, right? I solved the first question. Now let's move the next question. Like palindrome partition, palindrome partition, and the word search and tune problem. So we are going to solve each by each. So let's solve what this problem said, that you are given the string S and partition S. Okay. So such that every substring of the partition is a palindrome, return all possible partition. So what we have to do, we have to use recursion because the constraint is very low. So what we have to do, just we have to, we can like, yeah, we can use like what? First of all, let's see one helper function and the index would be 0, and what we have to pass, as, and the index would be, and the temp, right? And the return to, sorry, and the return, and we have to return answer, right? Now let's see how can we build it. Like if we want to write full code, code compiler. Let's suppose I want to write a full code, right? So you put this here, and the version should be, so this, let me see one thing. C++ 4.92. So is in this version 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 supported. Let me check one thing. Yes, include is JC version 1.0 GNU specific. Yeah. So most of company doing that, like the TCS or the Infosys uses the compiler of C++, that's 4.92 version, right? What we have to do, we have to just write the whole code of this question, palindrome partition. So the question is palindrome partition. We have to build, we have to what? Just we have to take, first we have to take the a string as input. So a string as a string a string as sin as, and the sin as. So call the vector string a string answer, vector string answer, which equal to, we should call the, we should call which function, we should call the partition function, right? So partition function, sorry, partition function with S, right? Now let's build. Now let's build from here. Now what we have to do it here? First void helper. Helper what? Index a string S, and the, okay, and the temp, right? So what we have to do here, just I is equal to index, index is equal to s dot size and I plus plus. First we have to check that if the each each pell, that means it is a palindrome, from where we have to check from the I and dx to I, right? If it is done, so yes, this is the palindrome, so we have to find, we have to s sub str str s, find the sub str, sorry, what what should be the starting point? The starting point should be I, and the starting point should be I. No, no. A starting point should be I and dx, and the I minus and dx plus 1. This should be, and the temp plus uh, it's like a temp plus, we have to use here vector, na, not a string, vector. Vector, why vector? Vector string temp. Okay, so temp dot push back app. Now call the helper function. Call the helper function what? I plus 1. Okay, we are taking here s and temp. Now again, just temp temp dot pop back, right? So this one. Now we have to check like bull is spell is spell. So what this s, this start, and this, and now we have to just st is equal to it. If the st, we are just taking the here the palindrome, right? If not, then return false, else we have to return true, right? So this one, this much I think, and the base condition is like if the I n x equal to as dot size, we have to just what, you have to just answer dot push back, answer dot push back what, temp, right? We have to just push it out and the return the function, right? Now the question arises, the question evolves that what is the here vector. So we take vector a string answer. Now let's try to dry run it using using let's suppose using a a b, right? So it's like okay. So we have to check if give here, right? Give here a string temp and temp temp. Now just see out x, see out x answer, see out x. The temp is not declared. Okay, so temp is not declared. We have to run the no man operator. Yeah, why? Okay, so we have to put it out like x x, and the cout should be x x operator and handle. So this should be a right answer. I think this should give the right answer. Sample input. Why time limit exceeded? Why giving the time limit exceeded? This my code is wrong. Let's see. Let's see if the my code is wrong or the compiler. Like why this give the wrong answer? I think this code is right. Let's try to try and let's try to submit here. Why this giving the wrong answer? 112, 113 expected answer. So what is the question? IDX. The starting point should be IDX plus plus 1. So it should be length s dot str, finding the IDX, the starting point to ending point. Then pushback, popback. Why this giving the wrong answer? It's palindrome. Okay. Sorry. We are not doing this, right? Now this should be giving right answer. Yes. So that's why this is, I think this should be provide right answer now. Yeah, 119, 1AB. Yeah, it's the right answer. Just remove this and add this. Yes, it is the right answer. And here it also passes. So this is the code. Just we are if partited. If the partition is palindrome, we are partitioning the right. Now let's see next question. Like word search. So it's a good question. You are given the n into m character. So it's like you have to make vector into character. So get line, set line. So you have to take input using get line and so let's first solve using this, what this question said. Word search given m into read characters string word. Okay, what you are giving. Okay, so return true if the exist in the grid, otherwise false. Okay, so if we find the word a, so we can go like from here and begin. If you find the word, okay, no matter how you are going, right? Yeah, like E, S, E. The word constructed from later or subsequent adjacent set, whereas horizontally but vertically in word. If the same letter may not be used more than once. Okay. So we have to use the visited one. Like, yeah. So horizontally and vertically should be neither. So what this question said. So it's like a, if we found one, we can go here and here, right? We can to left, we can go four sides, which can give our right answer. We can right answer, right? So like this, we mark out this. Now we get this B. Now we can this C. Now from C we can go here this. This we can get the so next character. So next we can take like word. We can remove the word. We can take an index for word, and we can take ik row and column. Okay, we can go off for side if the index equal to word size return true, right? Return true. Okay. So what we have to do now, we can travel from IDX all four sides, right? Yeah, we can check the validity in the we can travel from there and all the helper function. And if it is return true, it return true, and here we return false. Good. This one good. All good. Yes. Let's try to build it out. How can we build out like this? So it's more like a, just like we have vector board. So just take uh, bool helper paste a string as int. We have to take index for s and row and column for this, right? And what is the first? We have idx is equal to 4 and in dy is equal to 4. So what we have to do? Just -1 0 and 0, right? And 0 and 0 -1, sorry, -1 and 1. These all are, now we have to travel, we can travel four sides, right? We can travel from four sides, like new row, new r is equal to r plus ix plus ii, and the new c is equal to c plus dy plus ii, right? Now if we have to check, like if new r is greater than, sorry, is less than 0, or new r is greater than equal to n, that means column, or new c is less than 0, or new c is greater than equal to m. So we have to continue, because this is the out of boundary conditions, right? And what is n and m? N is equal to board dot size, and m is equal to board, that means one the size of the column and one is row. Now again check, also one condition we have to check, like sorry, if the board sorry, what is board का spelling? Board new row and new column is not equal to s dot index, then we have to continue. Otherwise what we have to do, just to do something incredible. Just if the helper, call the helper function again. What? Board, board, and the s, and the index would be 1 plus 1. Sorry, index, index plus 1, right? Index plus 1, index plus 1, and the index plus 1, and the row is no new row and new column, right? If it is written the true, so we have to return true, return true. Else, here we have to return false. Now just check here. If the index greater than equal to s dot size, just return the true function. True. Because now just call here helper function. What? Board function, board, and the word, and the index, and the row and column, right? Row and column. And what about if we not able to find anything? Okay, yeah, this one is good also. What about we not find, right? Like here we can't find. We can't move again. This is not a good. This is not good one, right? We have to move forward, right? What is the time complexity of here? Yeah, you can take like a 4 in in and is equal to mm, bo- board board dot size, and m is equal to board dot dot 0 dot size, right? And we have to check like row is equal to 0, row is equal to n, and row plus plus. Now again for column is equal to 0 and column is equal to m plus column plus plus. Now we have to check uh, if helper function, if helper function return, right? Board board word 0 and the r and c. So we have to return true, else we have to just return false. Let's see this passes all the test cases or not. I think this would pass all the test cases, but it fails on it now. Why? Because we have to not return false. In sorry, bull, bull return bull answer is equal to false, right? And what we have to do here, just now, just answer or helper function, helper function board word 0, sorry, index, index plus 1, new row, new column, column, right? And return here answer. I think this should pass the test cases. Compiler error, board, board is getting color. It's mistake of mine side. Board, helper function, index, word, word not s, and new column and new row. This giving the wrong answer. Why? For the false, it's returning true. Okay, so it's returning true. Why? Like we are find A, B, C, C. Okay. You have to just mark it down, right? What mark down? If you take in any element, right? If you take like a board, new row and new column should be mark it a star. What? Oh, spelling mistake. We have to mark down, right? Or you can take a visited array, but oh, I false. I can go. What? I think I'm actually. Why? Why it's return false? Why it's return false? We have to call 0 and 0. That means 0, 1 and 1. Called from helper function 1 and 1. And that could be 0, right? Now just we call the function. Should be matched. When we called current element should be matched. Okay. So it's like if n is equal to 1 and m is equal to 1, the return and what dot size is equal to 1, then we have to return the क्या? Board what? N minus 1, m minus 1 is equal to word is 0. I think this the question else false na else false false. Okay, sorry. We have to just this is not good. Just call from the function. Okay. If 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 the board R and C is equal to word 0, then we have to call from 1 here. Right. Just I think this much gonna solve all the problems. This gonna all solve all the problems. Yes, we are comparing, not analytic. Okay, okay. That's a false. It's false. Why it's returning the true? So it's like the more what 1 1. So it's called 1. Now we go 1 and so yes, just made now. Why? Just made. Just what we are doing. Just what you are doing. Just remove from here. Put it put it from here. Right. I think this is going to solve all the problem. Just make this. So what I'm trying to do, I travel to first what? What now? It's like the AA. So it's more like what here, what I'm here doing. What is pain, bro? What we have to do here, just like A A, okay. B C D. Okay. A B. Now we have just find here. So we travel to travel. Just find here. Now we travel back to here. Okay. So I think it's like a backtracking, right? From one path we can't find. So it's one can't the one path we can't find. We have to put back that path, right? So like the first character CH, first find the board new R and new C. Then we have to just board new R and and new C equal to CH. Oh sorry, star. And just after date we just put new R and new C, new C again to CH. I think this can match the aura, right? And here we have to just put R and C equal to this much. Character CH equal to board, a board of R and C, R and C equal to sorry, and the board R and C, R and C equal to a star, and just we have to check if we can't get R and C, then we have to make again this much. So this board. Now let's see if this passes all the test cases or not. If we can't find, yes. If we can't find the, then we have to put back it. So this is the solution of this. I think this might be right. So what I'm trying to do, if we the character match to the first index, we have to call the recursive function by putting that character on a star because the question suggests that you have to use only one it once, that means at most once, either used or not used. So this and call the recursive function. And again, we are if we are using, we are putting to a star mark, and so it's basically help us to prevent using the extra space of visited array, right? So this one is good. Now next, move to next problem. Next problem is like the queuing problem. So it's like the more famous problem. Let's move the next question, right? And queue problem is the placing of queue queue on an end-to-end chessboard such that no two queues attack each other. Okay, attack each other. So how can, given all the distinct solution of n1, you may return the answer in any order. This solution contain a distinct configuration. Okay, I got it now. But what? But what is the how and queue attacks? I think it's attacking diagonal or the column and the same row, right? So yeah, this is right. So we have to how to do? First, we have to travel how many to 4n. So we have to travel n into n cube, n into n. We have to just put it out. So I, so row is equal to 0. If we put that and we, for the putting of element, we have four options, n options, right? Let's suppose we give the coordinate row plus and call the helper function again. Now then again put back queen. So we have to just move it up. This row, if we put the row and the column, let's the row and column 0. We calling the row and column. If we put all the 0 here, if the queen is put here out, we have to check also from the valid point, right? Let's suppose column, it's valid, row, column and board. If it is valid, we call the helper function. And so it's like how can we build it, like can I use the void function? Yeah, let's build here. So what we have to do here, mm, let's use vector uh, we can use vector string board board what and what semicolon. Yeah, I think this what we have to do, we have to just call the helper function with the row and column and board and the board and the and, right? And return answer. What is the answer here? Vector a string answer. Now just call the helper function with int row row int column and the and the and the and the board, sorry, board and n. If the row is greater than n, greater than equal to n, we have to answer dot push back board, board, right, and the return. Now we have to check like for int column. If we can't give the column, I think this might be good. Good. No, we have to give the column, right? So column should be n and the column and column plus plus. If it is valid, what valid? So board board row board row and the column. If it is valid, so we have to just put row and column is equal to queen q, right, and call the helper function again with row plus one column. Why just we are calling the column? Can't we just remove the column section here? Why we are calling with row column? You have to know just this. I think this much good. Just column and board and the end. Okay. Again, we have to use like a row and a column is equal to point out. And what I am doing? Yes, this one is good. Now question arises, what is valid? So bool is valid. It's valid, right? So what we have to do? We have a vector, a string as board int row int column. Now first we have to check like the code. What we have to check first? First check there is no, there's also give one intent intent intent. First we have to check like 4 int 0 int n plus plus. If the board row plus ii is equal to queen. If it is queen, so you have to return false. Next, int ii 0, ii and ii plus plus. If the board ii and the column equal to queen if it if the row and the column already contain the QL. You have to return 0. Now you have to check like diagonally, right? How can we check diagonally? Let me first see that. Mhm. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So if we are here, we have to check diagonally for here. Yeah, yeah. No worries to check diagonally for the last two. You have to check this much and this much, right? So let's suppose you are here, you have to check this much and check this much, right? Let's suppose you are here, you have to check this much and you have to check this much, right? So it's not like this complicated question. So how can we use like this? Like how? Mm, you can use like 4. So if we are here, let me first build it out. So if we are here, like 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and the 3 and 2. Now we have to shift 1 and 2. More like a row and column, both are intelligent basically. Okay, okay. So we have to check like int r equal to row and c equal to column while what both both are decreases, right? While the row greater than equal to 0, sorry, r greater than equal to 0 and c greater than equal to 0, we have to check like if the board r equal to c equal to q, we have to return false. So and r, it's r minus minus and c minus minus, right? Now again r is equal to row and c is equal to column. Now again for while r is equal to n and c is equal to n, right? What we have to do here, you have to just upper bound the column, right? Column row. No. Hmm, column right upper bound. So in this situation also 0. Now what we have to do here, row and column decreases. So board if the board if the board r and c is equal to q, return the false statement or r minus minus c plus plus, which is good. So what we have to do here, right? Mm, this is good. This is good, and if we have to just return here the true. If all not written anything, we have to true. Let's see these questions solvable or not. Column, column. Where's the column? Okay. This much, right? Array dot pushback and the no matching function for pushback called what? Answer dot pushback? No. Why? Why not pushback? Board. Answer dot pushback? Not board. Why this? What is this saying? The function push by no patching called the push back. Why this? Not a no fetching function. Okay, okay, sorry. Test column. I think this much right, right. Okay, okay, and just column and no matching constructor. So board. So like what we have to do here and dot semicolon. Now we have to just now I got it. Why this giving the wrong answer? Not any answer. Board. And, okay, so column row column. Yes, this passes all the test cases. Let's see this passes all the test cases or not. Yes, this one is good one. Oh, what we have today? Just we have to this much function valid checking right. Checking the function. Now let's move the next question. So the rate in match. What this question said? Consider the rate is 0, 0. Okay. The rate goal to reach the destination is position n minus n2. The rate can move in the four direction possible. Okay. Left, right, up, down. The matrix contain only two possible value. 0, that means cell is blocked, and the 1 that can be passed through. Your task to find the all possible paths. Okay. That rate can take to reach the destination. Okay. So from the source, from the starting to ending, under the condition that rate can't be revisited. Okay, not be revisited. Okay, revisit the same path. Okay, furthermore, the rate can only move to its adjacent element that can within the boundary of not selected. Return that. Return the lexicographical smallest. Okay, so what we have to do here? What we have to do here? You have to just like uh, we have 1 0 1 0 0 0 1 1 0 1 and the 1 1 0 0 and 0 0 1 1. So if we take this apart, so we are stating we can down 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 right down left left left. Okay, right right right. So down right. Okay, right. Again, what we have to have? So right, down, down, right, down, right. So this is two possible ways. So what we have to do? Yes, you have to do here. How is the constraint? It's a constraint of 5. You can use the recursive solution, right? So how can we use the recursive solution? First, let's see here. Mm, you have two positions, right? We have given two positions. Mm, so what we have to do here? We have to work. Mm, there must be a solution like how can we proceed this? If we make LRDU, if we make this much LRDU, so it's like the growth of if we going travel back. Okay. We can do it. We can do it. But how much? If we check 0 and 0, we have to check 0 and 0, make everything free, and if we move through, so answer dot goes back, right? So what we have to do here, just make a helper function, and what we have to do, row, column, mage, and anything else, a string temp, sorry, one empty string. Now return the answer. So you have to sort now. Sort the answer. Answer begin because it's say that lexicographical smallest. And now just return the answer. Now just now we have built a vector, a string, answer, and make a helper function like make helper function is like a row column and the vector in and the maze. First we have make the ix is equal to 4 and int I divides 4, so it's and the string we have also we have to make a path. Now let's first build 0 comma 0 comma -1 1, right? This one. Now again 0 sorry 1 comma -1 comma 0 comma 0 And let's see that how much to proceed this. What if we are standing on a left right 0? So if we are standing on this, we have to increase I. So we are going down. So it's a D. Again, if we are here, we have to row 0 and column, so it's up. Now again, we are minusing the row. It's a left, and the positive, it's the right. So this much. Now let's see how to proceed. Like in I equal to 0, II plus equal to 4, and II plus plus. So new R should be rho plus dx plus II, and the new column should be what? Column plus new C plus II, right? This one. And the path should be, first check the validity, it is valid or not. So if column should be negative, or the new C should be equal to M, or new, what is M, or new row should be negative, or negative, and new column should be greater than equal to N, we have to, or the board, oh sorry, mage mage new R, or new C equal to 0. So we have to just continue. Sorry, continue. Else what we have to do? Else just mark mage R, and new column 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 equal to 0, and uh, and and what, you have to take a helper one as string temp, right? And just call the helper function. Helper function what? uh, New R, new column. Okay, new R, now new column, mage temp plus equal to path by II. Again, call the mage, and R new R new R new C equal to 1. This much. And the base condition is like, if the row equal to n minus 1, and the column equal to m minus 1, we have to just answer dot push back a temp and return. So this is what is an image dot size, and what is m should be image 0 dot size. Right. So this much is good. Let's see this. Run the test cases or not. Dx new column will not declare. Column, oh sorry, dy new RC will not declare. Okay, new C, new R, new C, new R, new C, new R. Segmentation fault. Why? 0, 1, 2, 3, IDX. If it is greater than C, greater than and negative, else if it is 0, we have to continue or make a continue or call the function make function make new r if it is answer dot py push y. So it's like a more by segmentation fault it's giving. Okay, just mark down right. Calling from the helper function, just mark down helper. Okay. So if the image is equal to 0 and is equal to 0 is equal to 0, then we have to just return the empty vector empty vector. Now just mark down 0 0 is equal to 0, right, and call the function. So it's again giving you the segmentation. Why this giving the segmentation and it's equal to a greater string match temp size answer dot begin answer dot size, all are good. Why still giving the and for row idx row column checking, row checking, and image checking, marking one, calling other as a function. Why this the segmentation called marking row main column? It's out of one. Okay, sorry. This should be this. Yeah. Mm, Okay. So reverse cam dot this now this now but answer dot push back reverse reverse cam dot begin. Just reverse the answer. Cam dot end. Again dd. Why my answer is dd ddrr. Why I made a mistake in here and here ddr dr. This is good. A second question dd d. Second one I thought that dd. Okay, your expectation rd rd. Okay, so why 0 1. Okay, so it's like a down, first down. Now it's minusing one, so it's like a up. Now it's minusing in a row, so it's like a left and plusing in a row. Okay. Now I get it. Why this like first down up, because this is the now I get it. Now I get it. Why this is giving the wrong answer? Like the column, this one and this one and this one. So like if we adding, so we are adding column plus one, so it's right and left. We are minusing, so it's up and it's a down. Now this should give the right answer. Not completely wrong. Yeah, we are just making a bubble. So right. So this one, the red made solution. Now let's move the next question. I solved it. What breaker? word breaker. What this solution? Question word breaker. Mhm. So word breaker, given the string S and dictionary of a string word list, return true if the S can be segmented into a space separated sequence of one or more dictionary words. Okay, so lead code. So lead plus code. Yes, code. Okay. Apple, apple, pen, apple, pen, apple. It's a true. Right. Apple can be segmented. Apple, pen, apple. Okay. What we have to do? What you have to do? You don't have to just find. Let's suppose dictionary. You lead code. Let's suppose you find this much. This much. If you find this much, so let's suppose find this. Yeah, yeah. Now I got it. Like the A double P P L E P N E A P P L E. Right. The dictionary words all go into the go into the map, and we find the if it's available. So yeah, available. If you're not available, you can process. So what is the solution of this code? What can be the solution of this? What can be the solution of this code? The question. So this might be the solution. Let's let's think how. So how then use the map, unordered map, unordered. A spelling is good. Unordered map, sorry, int, a string, and a disk. Yes, disk. Now put all the disk, sorry, disk, 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 x plus plus, right? Now just call the return the helper function, helper function with what index 0 and s0, right? And just build build helper function. We have index 1, index, and the a string s, right? What this question suggests, like how can we approach like this, like this one? So take a bool answer, mark it out false, and start from the I index I s dot size and I plus plus. So take like if 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 the dix dot count s dot sub str, what starting from the index and ending from the index plus one, right? If it is present, then we have to call the I plus one and s. If it is returned the true, we have to return true. Just just mark it down, like Alpha function I plus 1 s, right, and return the answer. Now what is the base condition? Base condition should be like index. Index should be greater than equal to s dot size and return true. Let's see this passes all the test cases or not. Oh, what is okay? Yes, this dot font stx. Yes, this should pass the test cases. Let's see it's submittable or not. It is submitted or not. So the pass, please pass. 10 रुपए 10 रुपए 20 रुपए 20 रुपए. Time limit exceeded. Okay, let's keep the time limit exceeded. What is the size? How much the size? Okay, please. Ah, mm, A present, A plus plus present, A plus. Let's see all these are present. All things are presented. What we have to do here? If all things are present, then I memo it. All strings words are unique. So I store all the words for here. One, 2, 3, 4, 5, 6, all set. Let's give the clearly what can do now. Like how can we can I use the string as can I use the DP 1D DP? Yes, 1D DP. Let's try to do DP DP 300 mean set DP minus 1 size of DP, right? Uh, what if the DP index is not equal to, then we have to turn DP 1, sorry, DP index, just in a slice DP index. Yeah, it's a DP problem, but I don't think we can use DP. I solved using DP. I use the DP, but let's see how can we less than without using DP. So let's see the other solution of all this. DP using dynamic programming. DP all are using DP, right? DP. So okay, let's let's ask from the chat GPT. What problem? 31, right? So, so lead code, lead code problem. Can can I able to solve using recursion with without DP. Yes, can be using the pure recursion without DP. Like this one. Yearly happening recursion use so splitting B, MMO, same logic. So inversion memorized. Time complexity itna. So this saying that we can solve using this, but I don't think we can able to. Let's try to use this. I think this gives the TLE, right? We have to use DP. So the complexity without DP is 2n, essentially worst. So that's why. So we have to use the DP here, and the problem. Okay. Now let's move the next question. I'm coloring problem. I'm coloring problem. So it's a graph problem, I think. So let's there is a present, so why not use the LeetCode? Now, by copying the solution, flower with no adjacent, no flower planting with no adjacent. You have an garden, one to an array where the path is I to I described. Okay, describe the bidirectional path. Okay, in each garden you want to plant one of the four type of flower, one of the four type of flower, one of the four type of flower. All three plants have at the most three paths coming to giving to your task to see the flower type which the two garden connected by. I don't think this is the right one. And this is the problem. That's a completely different one. You are given the undirected graph. Okay, undirected graph. Usually represented by it with integer of m. Integer of m. Okay. So you task to whether it's possible to color the graph using at most m different colors such that two adjacent vertex, no two adjacent vertex and same graph is same. So what we have to do? Mm, So, so you have at most use. You can use the coloring here. What we have to use? What you can use? I think this is the problem of what? I don't know the algorithm, but I think one graph algorithm is just like this. I don't know. I don't remember at current position. Right. So what we have to do here? What is what we have to do here? Like 0, 1, 1, 3, 2, 3, 3, 0. So we have, let's suppose we make a adjustment like 0, 1, 2, 3, 1, 0, 3, right? And 2, 0, 3, and 3, 0, 1, 2. Now let's suppose 3, 0, 1, 2. Now let's suppose we have initialized into 1. Now we can't be able to give on these three. We can't give the is. So it's a parent. Now it's give the 2. We provide 2 as a 3. So now let's move the 3. So can we give the 3 on this? We can't give next and plus 1. 1 plus 1. Just use it to the what is the M color MBX? Can I able to solve using the two color here? So it's a 0, 1, 1, 0, oh, 1. So it's a 1. No, no, you have to use three colors. You have to use three colors, right? So what we have to do here? First we initialize one. Now first, then we can go give it is two. Now, let's suppose now from the one we can't give the three as a one. 0. That means one, two, and the two and the three. Okay, two adjacent elements. If we provide this one, so we give them two. Okay. Now call from the one. So this parent now. So we have to give three to this. Now again, let's we have to build up. Sorry, right? We built a vector 3. Now again from 3 it's provided. It's provided from 3. We can't give the 3. We can't give 3. Can we give the 1? We can't give 1. So all the parents we can't give 1. Let's suppose give 1 1. From this all the parents 1, we can't give the 2. So it's parent, so it's the 2. Now from the 1 can't give anyone. It's we provided is 2. So we have provided give the yes 2 is already present. Now it's 3. 3. It can't give the 3. All of markdown. So we have to use here the approach like graphical approach. First make our adjacent element 1 1 and 1 2 3. Then we make like what is the next question, right? So local and expression add validator. So we have to run by selectioner. So what we have to do here? How to adjacent same color like for 1 or for 1 for 1 and we have to go 1 2 and 3, right? And from 1 we can go 1 and 3. From 2 we can go 0 and 3. And from 3 we can go 1 0 1 2. So let's suppose starting from the 0 we provided 1 1. Now it's giving to 2. So it's provided 2. Now it's giving to it's not. So it's provided 3. Right. And falling from this now we have to provide. So it's provided already. It's provided already. It's provided. We have to go 0. No, this is not a good question. Then what we have to use here? What we have to use here? So it's like so we have to like node 0. We can provide the node is this length. Just provide like Just give just give 1 0 to 1, right? And check, check traveling all, checking the node 0, node have 0. Now if it is 0, if it is safe to provide the 1, we have to mark visited is equal to I, visited is equal to I, and call that function, and else we have to just return. It's also a recursive code, right? What is the time complex? It's a 10, so it's also a recursive code. So what we have to do, like for we have to do just what? Like if 0 is equal to node 0, so we have to check like it's not equal to code, right? It's not to have a code. So what I'm trying to do here, uh, just just make a vector in vector in color colors, right? And if we make a adjacent element, adjacent vector like a adjacent vector, so just you have to travel this. You have to just travel this. Like one. So all the elements should be, it is safe. Okay. Mm. Just made a un vector, right? Un unordered, unordered, unordered map in vector in vector in adjacent, adjacent, right? And just put it out like photo x edges into u, x is equal to 0, v x is equal to 1. So adjacent dot push, sorry, u dot push back v, and adjacent dot v dot push back u. You right. This one, this one is good. Now call the helper function from what? Node. What is node? 0. Node 0 and the visited and the colors. Sorry, colors should be only colors, right? And call m and nothing, and call the v, right? And uh, just make a void, just a boolean function, bool helper what? It's node and what? Vector in visited, sorry, colors in m, int m and int v. So if the node equal to v, just return the true function, true, true. Now just initializing, just coloring the, if is valid what? Colors colors node, node color and node, and I, that means it, this correct. If it is good, So we have to just color, but node is equal to I, and if the helper function return the node plus 1, node plus 1, and the color and the M and the V, and return the true, and the color 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 I is equal to 0. So it's like the if colors 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 0. Now good one. It's not a good one. It's a bad one. Now just return the false. Sorry, return the false. Now bool is valid. What we are calling from the color in color, and what int node and in color, 4 auto node, sorry, adjacent node, right? If if the colors if the colors of x equal to color, then we have to return false, else return true. Else return true. Is valid colors were not declared in this question. Color 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 Yeah, this is returning the true. Let's say passes all the test cases or not. Yes, this passes all the test cases. So this one is good. You have to just recursively try to backtracking, try to putting all the colors on it. These are the good. Now let's move the next question. This side bit. Now next move the Sudoku lover, and the next is expression aid operation. And for POTT problem. Number sir. It's a good theory section. So now let's move to next question. So local over and expression over, both are solved. Solve. So write a program to solve a Sudoku puzzle by filling the empty cell. A Sudoku solution must be satisfy all the conditions, all the following rules. Each of the 1 to 9 must exactly once in a row. Okay, in a row, in a column, and I will. Okay, now get it. Very good. What we have to do? Just you have to nothing to do. Just take a row and a column. Not a row, only row and a column. Row, column. First, Board is going to board 0 and 0. If the column is equal to 6, then we have to go outside if the row. So we can answer. After the column, which you ended. This is good question, right? So this is Indian profile. So let's solve the question number second, right? Sudoku solver. How, how can you proceed that? Like just you have to call a helper function. The function contain the board, row, column, all. Yes. Now just void helper helper vector 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 character and board board int row and int c. Now just read it like 4 int I is equal to 0. You have to take like I row and column. So what we have to do for each function you have for each one you have two option. What for each one you have two option till 9, right? Plus if what we have to do if the board row and column yes, if the board row and column is not equal to dot, just call the helper function with row, row, board, 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 row, and c plus 1, right? And we have to check here if valid is valid of a board of putting the eyes with a row and the column. If it is, then we have to just board row and the column is equal to I, or call the helper function. What the helper function do? It calls I, R, and C plus 1, and again board, R, and C is equal to dash 1 input. Now we have to just check if the C is equal to M. So we have to call the helper function with a row plus 1 and column should be 0, and then the board and the row r plus 1 and column should be 0, and if the if the r is equal to n, so just return the true. Why true? Return true. If yeah, now we have to call the valid function, right? We have to call valid function, right? Board size m is equal to board 0 dot size. Now bool is valid, just copy from there, copy, paste here, and enter row, int column, int value. What we have to do? Just 0, 9, plus plus. What we have to do? If the board, row, and II is equal to 12, 12, 12, or the board II and the column minus 0 equal to well, just return the call the statement. And another one, right? You have to find the row, new row is equal to, and a new column. Just what we have to do. 0, 1, 0, 1, 2, 3. All 3. What we have to 3 from the row divided by n. So it's give the row number, right? It's give the row number. Yeah. 1, 2, 3, 4, 5, 6, 7. 7 divided by 1, 2, 3, 4, 5, 6, 7, 8, and 9. 7 divided by 9. It's not give a row number. How to find row number? Which is the what? Do I find row number? Just we have to find that how much the index, right? Like which bucket is. Oh, it's like here we have row number 1, 0, 1, 2, 3, 3. 3. So it's my 4. Starting index should be 1. Right. So how to approach this? How to solve, like how to do this? Mhm. This one is good. We are traveling. So if we take the 0 plus 1, we can't. Okay. So I am here. So this is so it's more like a 0. You have to satisfy all the following condition. Row is good. Now we have to just find the row. So it's more like a find the starting index should be like what the starting index would be like 1 2 sorry 1 2 3 4 4 4 row 4 row the starting should be 4 by 3 it's a 1 and column should be then yeah so it's like a row divided by 3 into 3 and the column should be column divided by 3 into 3 and now we have to check the condition how condition like 0 3 plus plus and the j is equal to 0, j is equal to 3, and j plus plus if the board new row plus I and the new column plus j minus 0 is not equal to equal to value, just return the false. Now else return the true. Where board board, board, and the board, 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 and the board. R in column, R plus the column is valid. So board. Why this? R plus 1. Yes, R plus 1. If the R is negative 0, yes, alpha. It's the false. Always return false, not a true. Na? Why is access? The only count read access memory. Oh, sorry. It is a value. And it is a row and it is a column. I understand why this. Yes, let's try to submit it. Yes, it passes all the test cases. Good one. Now let's move the next question. This is question. The question is so from the yesterday, solve this. From the tomorrow, I'm going to solve the tree problem, right? I'm going to solve binary tree, all problem of binary tree related, right? From the tomorrow, we have to solve with these two questions I have so solved. First, let's solve express add operator. 1, 2, 3, 6. Okay, you have to find the target of 6. Okay, one into the one. Next, what we have to, okay, addition. You have 1, 2, 3. So can I take? Yeah, you can take that tracking. Plus 1. Okay. Each, each. Okay. Okay. Each position, you have to push. You can put each in each position. You have put plus into. From each position, you have given the So all possibility insert the banished search digit between them, and you have to find the this is one of the good question. So I'm going to solve this tomorrow, right? That's it for the today, guys. Because it's already time. Thank you. Thank you for watching. Nice day.